Hey everybody, today is Monday, April 20th, and I wanted to start off with a little update about my worms. Something happened this weekend, and I wanted to share it with you guys. So I had to feed them again, and I told you that, okay, so they're in the little container, and I've got all the food on the one side of the container, and all the research that I read said to feed them on the other side of the container so that they will migrate, and then kind of those worm castings will be sort of throughout the entire bin and not just clumped up over on one side. Okay, cool. So I did that. I put the food down below. I piled some new peat moss and newspaper shredding on top of it, got a little bit wet, everything's great. I put the lid on, and then we made breakfast, and we had some more banana peels and some strawberries and that kind of stuff. And so I thought, okay, I'm going to go ahead and put those back in there since I just fed them. I wanted to do that. So it was maybe an hour after I did all that. I took off the lid. Oh my gosh, like 200 worms were up on all four sides and on my lid. Like they were trying to figure out where the food was because they didn't know where it was. They were migrating to try and find the food, but they were obviously not going through the dirt. And I didn't realize that they would go up to try and find it. So I was panicking, and I'm like, how do I keep them in the dirt? And get this, worms don't like light, which we knew that, but they don't like light. So they said when you feed them the second time, or every time you feed them, leave the lid off and the light on. And so they'll stay down in the dirt. So I did that, and it worked just fine. Isn't that crazy? So I'm learning a lot with these worms. They're pretty interesting. Okay, today we're going to talk about, I'm going to share my screen real quick. This and this. Okay, so today we're going to talk about standards 784A and 784B. So 784A is construct a scientific explanation based on evidence for the role of photosynthesis in the cycling of matter and flow of energy into and out of organisms. So we're looking at producers and how they use photosynthesis in order to create energy, and then that energy will flow through matter as different organisms eat the producers. And then 874B says develop a model to describe how food is rearranged through chemical reactions, forming new molecules that support growth and or release of energy as matter flows through an organism. So we're going to be looking at a model today called a food chain, and the food chain will sort of help explain how energy goes from one organism to the next, and it does so through a series of chemical reactions. Okay, so I've got to stop sharing this. And then I am going to share my desktop. And then I can share this with you. Okay, so today, you guys, I have, I'm using a PowerPoint that I found online. I actually went to a website called Teachers Pay Teachers, and it's where teachers will come up with different lesson plans, PowerPoints, things that they use in their classrooms, and then they sell those, and so they get a little bit of money for what you use. This was a great PowerPoint, and I want to give credit because if I didn't, then you guys would think that it was my work, and that would be plagiarism. So I'm giving credit. I actually had to reach out to them and ask them for permission for me to share this with you guys. And I received permission, and they just asked that I would give them credit as the owners. And so Getting Nerdy with Mel and Gertie is the name of their company, and I'm going to attach a link below if anybody is watching this video and wants to know where I got the information. All right, so we're going to start here with this. This is you guys probably can't see, but I'm going to move there we go. All right, so this is like a bell ringer that I would have normally, and it's just identify each organism. I've got them organized in this long kind of pattern. This is called a food chain, and we'll talk a little bit more about that on the next slide. But let's just review real quick. I gave you guys vocabulary words last week, and I wanted you to make sure that you're studying those vocab words. So I want you to look at these pictures and identify each one as either a producer, decomposer, herbivore, omnivore, or carnivore. Okay, so let's first start right here. We've got energy from the sun. That is paramount. Everything always starts with energy from the sun. And then from there, we have a strawberry plant. So I'm going to give you guys a second to decide which one of those labels the strawberry plant is. Okay, so the strawberry plant is a producer. It produces its own food. It will also use food or nutrients from the soil. We'll talk about that in a second. But it uses the reactants are carbon dioxide and water, yield, glucose, and oxygen. Okay, so carbon dioxide and water have a chemical reaction, and those atoms rearrange to form two different substances. Glucose, which is starch, sugar, carbohydrates, whatever you want to call it, but it's glucose, and oxygen. Okay, so what about the next one? What about the grasshopper? What do you think that is? So grasshoppers and other insects are, well, actually, this particular, because some insects do eat other consumers. Grasshoppers typically do not, and so we would consider that as a herbivore because it just eats the produce. The producer. I was going to say produce because you guys, have you ever gone to a grocery store and you walk into the produce aisle and it's vegetables and fruits? That's because those come from producers. So everything that you would think of to see in a produce section of a grocery store, you know that those come from producers. And those fruits and vegetables are the stored energy. That's where we get our energy, because that is the fruits and the vegetables have that glucose in it. That is the stored energy for the fruit, for the plant. Okay, so grasshoppers are herbivores. How about the mouse? Well, we're looking at the mouse and it's going to eat the grasshopper. So we think, okay, it's a carnivore. But actually, mice are omnivores because mice will also eat grasses and berries and both producers and consumers. So we'll consider that an omnivore. How about the snake? Snakes are strictly carnivores, okay? And then how about the hawk? So a hawk belongs to a group of birds called birds of prey, which they only eat meat. Some birds do eat producers, they'll eat nuts or berries or seeds, but the hawks don't. So the hawk is a carnivore. And then how about this little guy? How about the mushroom? The mushroom is a decomposer. And so this whole thing is our food chain. And what's important is that you guys look at the arrows that goes from each organism as we model the flow of energy from one to the other. So I want you to think about what the direction of the arrow what the direction between that the arrow points between each organism. What does that mean? What does that signify? So we've got from the producer to the consumer here, the first primary consumer, that arrow is pointing to the primary consumer. Why do you think that is? It's to show the flow of energy, where the energy comes from and where it goes. So the energy starts from the producer and flows to the grasshopper. Okay, it's really, really, really important that you guys understand that the direction of this arrow is very important when you're talking about a food chain, when you're talking about the flow of energy from one organism to another, and how we're showing that cycling of energy. So a lot of times people, when they first look at this, they want to say, well, the grasshopper eats the produce or the strawberry plant. And so I'm going to say the grasshopper eats it. So I'm going to point from the grasshopper to the plant. That is not right at all. If you can just remember that we are looking at the flow of energy and where the energy comes from and where it's going. Okay, so that's why we've got an arrow pointing from the grasshopper to the mouse, because that's where the flow of energy, the mouse is getting its energy from the grasshopper. which got its energy from the strawberry plant. And the snake gets its energy from the mouse that it eats. So that's why that arrow is pointing in that direction. And the hawk gets its energy from the snake. So again, the arrow is pointing to the hawk. It's showing the direction of the energy. And when that hawk dies and the decomposers start to break down the nutrients from the hawk, it'll get its energy from the hawk. So the energy that the mushrooms need in order to live and reproduce and do what they need to do, it'll get that from the hawk. And then everything else is going to go back into the soil. And that's where we need all those extra nutrients like nitrogen and so other nutrients that plants need in order to grow. A plant is an autotroph, meaning that it will make its own food. It makes glucose during photosynthesis, but it needs more food to grow, okay? So that's why we've got fertilizers. And so the nutrients that the mushrooms get naturally, those are natural fertilizers, and you wouldn't have to use synthetic fertilizers. So this is called a food chain. Okay, so a food chain is, it shows a series, I can't see because my little picture's in the way, hang on. A series of events in which organisms eat one another and they obtain energy. And each level is called a trophic level. We're not going to worry about that vocabulary. The vocab that I gave you is just fine. And it always begins with light energy or energy from the sun, okay? All right, let's go back to photosynthesis and find out like how does this work? So if you remember, this is the chemical formula for photosynthesis. So we have 6 individual groups or molecules of carbon dioxide plus 6 molecules of water plus sunlight and chlorophyll yield 1 molecule of glucose, and that's C6H12O6, and 6 molecules of oxygen. We get water will come up from the roots, and the carbon dioxide enters the plant through those little teeny tiny holes called the stoma or stomata. All right, the oxygen will exit the stomata, and the glucose is stored, and it's stored right here in the little strawberries. This is where we store, or where the strawberry plant will store its food to pass on to the next or to use itself. Okay, so then we have the next level from the primary, or from the producer then, is your primary or first level consumer. And this is either going to be a herbivore like the cat or like the grasshopper, or it's going to be an omnivore, because look, mice eat produce too. Okay, so then we have our secondary level, and the secondary level will always, if you remember your vocabulary definitions, it will always be a carnivore, and that carnivore will either be an omnivore or it will be an omnivore. It could be carnivore or omnivore, either one, but it's going to eat the primary consumer. Okay, so we could say in the food chain that we were looking at, the mouse ate the grasshopper. Or if the mouse was the one that ate the strawberry plant, then the snake would eat the grass, or the snake would eat the mouse. That would be a secondary level, secondary consumer. And then we have the tertiary, or the third level. I don't think I included this in your vocab. It can go on, because nature isn't just a really simple 1, 2, 3 step, that's it. You know, there's multiple steps sometimes when we're looking at what animal eats what. So this is called the tertiary or third level consumer. And this is the thing that eats that secondary consumer. So the snake eats the mouse, or the hawk eats the snake. So the scavenger is going to eat the leftovers. We didn't have the scavenger in our food chain, but we certainly could. The scavenger is going to take all the leftovers, and they're going to break down any decaying material and release the nutrients into the soil. That's the decomposer right here. Okay, so we've got our producer, we've got our primary consumer, secondary consumer. This is a third level consumer. This is the tertiary consumer, and then our decomposer. This is a long food chain. This was a really good one. And notice where the arrows point. So because sometimes grasshoppers and mice, they don't go through the food chain. Maybe they die before they're eaten. And as they're decomposing, then the mushroom or other decomposers will get those nutrients from them as they decompose. So that's why you'll notice that the grasshopper gets the energy from the strawberry plant, and the mouse from the grasshopper, and so on and so on. But we could also say, hey, guess what? My strawberry plant died. And as it's decomposing, that energy is going to go to the mushrooms. And maybe my grasshopper dies before it gets eaten. And that energy will be transferred to worms, mushrooms, bacteria, whatever the decomposers are. Same thing with the mouse, with the snake, with the hawk. Okay? All right, so here is our food chain, and I'm going to show you a couple other ones. I'm going to stop that. There we go. So here's one. Let's say we've got a stump, and the stump has slugs. Let me go back. We've got slugs that live on the stump. The frogs eat the slugs, and the snake eats the frog. Look at the arrow. It shows the direction or the flow of energy from one organism to the next. Here's another one. We've got a thistle plant, and snails like to eat those thistles, and birds like to eat the snails, and the hawk will eat the bird. Again, notice the flow of energy, okay? And then the last one I want to show you, blueberries, a little fat mouse, and a ferret. So it can be long and it can be short. A food chain is, well, there's not just one type of food chain. It can change. This is the last slide I'm going to show you today. We're going to move on and say, okay, what happens if we have more than one food chain in an ecosystem? I'm going to show you what that looks like later. But for right now, here's your assignment. I want you, let me stop sharing. Okay, I want you to go back to Schoology and go to the discussion board. And I'd like you to reply to the discussion board. This is part of your assignment for today, okay? And you'll just have to write a response. Let me know if you have any questions, and we'll continue to move through and talk about food chains this whole week, all right? Okay, you guys, talk to you later.